Welcome back, students. So this is lecture number 2, in which we will discuss about semiconductor material, different kind of semiconductor material. So we will revise once again what happened in this one, what we have discussed in the last lectures. So we have covered up to semiconductor material, then covalent bonding and intrinsic material is remaining still, then energy levels and extrinsic material is still remaining. Okay, so we have discussed that what is the use of semiconductor material. So whatever the semiconductor materials are there that are used in, we are using in our laptops, then computers, then every electronics device is made up of every electronics. I'm saying every electronics is made up of semiconductor material. Okay, so these are the very famous examples like your smartphone, then camera, then hard disk, then every internet, and then microprocessor, then micro SD cards, computers, laptops, etc are the applications where we are using the semiconductor material. So the different kind of semiconductor materials are silicon, germanium, and gallium arsenide. So broadly categorize the semiconductor material into single crystal and what you can say single crystal and compound. So single crystal is germanium and silicon, and the compounds are cadmium sulfate, gallium arsenide GaS, then gallium arsenide phosphorus P. Okay, so we have discussed this thing. Then we have discussed that what is the importance of each and every, that is silicon and germanium, why we are going for the germanium or why we are going for the silicon, because we know that the transistor made of silicon is having five times faster speed than the silicon one. Okay, so now this is in this lecture we will see this thing. So in the periodic table, in the group 4, okay, the group 4, we know that periodic table is divided into this rows and columns. Okay, rows and columns. Right now you have to tell me how many elements are there in exist in the periodic table. You have to tell me in the comment box. Comment box is open to you. So you have to tell me how many elements are there. Okay, and what is the significance of row and what is the significance of columns. Okay, what is called like this one, what is called like this one. Okay, so these are nothing but what you can say the horizontal elements are there, that is the horizontal like this one are there, we are calling what you can say, it is calling as something, and the column is calling as something, that something is nothing but the groups. Okay, so that is nothing but the groups are there, horizontal columns are groups one. Just a minute. Okay, so silicon is having the electrons, the electron, there are 14 number of electrons are there in the silicon, and the germanium is this one is having 32 electrons. Okay, so if I know the distribution of this one, so how they are distributed, that is nothing but 2 in the first orbit, in the second orbit 8, in the third orbit 2 plus 8 10, and remaining are how much, 4. So 4 valence electron is there in the last orbit. The valence electron is nothing but the number of electrons are there in the last orbit. So how many electrons are there? There are 4 electrons are there in the last orbit. Okay, so and as far as germanium is concerned, so the electron distribution in any atom is given by the formula 2n square, where is the n is the number of orbit. Suppose n is equal to 1, then first orbit, so 2 into 1 square is 1, so how much in the first orbit you will find 2 electrons. In the second orbit n is equal to 2 square 4 into 2 means 8 electrons. In the third orbit you will find 3 square 9 into 2 18. So this is nothing but the 8 plus 2 10 plus 18 to 10 plus 18 is 28 plus 4, I think 4 are remaining. So we will say that in the germanium as well as silicon we are having 4 electrons. So whatever the electrons are in the last orbit, we are calling it as a valence electron. So germanium Ge and silicon are having 4 valence electrons. So as far as electrons valence is concerned, if 3 valence electrons are there, okay, I will tell you 3 valence electron there, it is called as trivalent. Okay, trivalent. 4 electron, then it is called a tetravalent. and 5 electrons are there, it is called as what? Pentavalent. Keep in mind what I'm saying. 3 electrons trivalent, 4 electrons tetravalent, tetra, 5 electron pentavalent. Okay, so these are them. So we know that these are the electron configuration of germanium and silicon. So that 14 is nothing but what? Atomic, what you can say, number. So atomic number, and atomic mass is nothing but number of electron plus number of neutron, because we know that the number of electrons and number of protons are the same one. So number of electrons and number of proton are the same one. So any atom is electrically neutral in this case. Any atom is not at all positive charge or negative charge, it is electrically neutral. And if you know that gallium is having 31 electrons are there, so as we know that in the germanium there are 32 electrons, so 31 electron means nothing but the 3 valence electrons is there in the gallium. And in the arsenic we know that 33 electrons are there, so 33 means what electron is there? 4 plus 1 is 5 electrons, so we can say that that is the pentavalent. Okay, so we will revise the things. Silicon and germanium 4 valence electron, then gallium 3 valence electron, and the arsenic As is having 5 electrons. So this is the tetravalent, this is trivalent, this is a pentavalent. Okay, so we will see why we are using this 3 only. Okay, so whatever the electrons are there in the last orbit, means silicon is having, suppose silicon is, this is the structure, suppose this is silicon structure. So 4 valence electron in the last orbit, because every orbit, remaining orbit are the they are complete one. So the whatever the last orbit are there, they are try to find some electron in the nearby atom, and they will complete their octet. And octet means 8 electrons. So this silicon will cover up with this one, and this one. Means already it is having 4 valence electron, 1 2 3 4, so it will share one of these, second, third and fourth, so it will complete his octet. So what will happen? It will complete his octet. They are whatever this what you can say, the bonding of this is called as covalent bond. What you can say, it is called as covalent bond. Okay, so what is exactly covalent bond? They are sharing the electrons with the neighboring one, which are valence electron, they are sharing with each other. Okay, so likewise they are sharing one. So this bonding of atoms strengthened by the sharing of electron is called as covalent bonding. Means what will happen? Though whatever the last orbit are there, they are loosely one. So how energy levels are there, I will tell you. Suppose this is my what you can say, nucleus. Okay, nucleus is having, and electrons are revolving like this one in this particular orbits are there. So whatever the electrons are there that are in the nearer to the, suppose this electron and this electron, so nearer to the nucleus, it is having higher energy, so they will not go for the conduction. But whatever the electrons at the last orbit, they are loosely bound, so they can go for the conduction when some external energy is given to this electron. Means what will happen if you are bombarding some photons, light energy, then electrical potential, then this electron will release and they will go for the conduction. Okay, so likewise this will happen in the silicon as well as germanium, both cases. Okay, so as far as GAS is concerned, so AS, we know that in the arsenic we are having 5 electrons. Okay, so that 5 electron, this one 2 3 and 4 5, they are forming with 5 gallium. Means this is first, this second, this is third, this is fourth, and this is fifth. Okay, means one gallium will go for the 3 arsenic, and 1 arsenic will go for the 3 gallium. Okay, because we know that in the gallium, we are having 3 valence electrons, and in the arsenic we are having 5 valence electrons. Okay, so they are forming the sharing the electrons. So whatever this configuration is called as covalent bonding. Okay, So covalent bonding is like this one. So why we are going for this covalent bonding? Because they will strengthen the atom. So these loosely bond will characteristics will be less fun. Okay, so till now we have seen covalent, what is meant by covalent bonding, what is meant by covalent bonding, then intrinsic material. Okay, we have seen intrinsic material, then we have seen the covalent bonding of silicon, germanium, and we have seen the GAS bonding. Okay, so till that we will stop over here, and we will see the next bit in the next lecture. So thank you very much for attending the lecture. Thank you.